Hi everyone.
Hi,
Um,
hello.
so today we're just gonna be talking about only lines, and then tomorrow we can finish off uh with planes, because lines and planes they kind of like summarize everything, right? So with lines, we've got three types. I mean, not three types. We've got only one line, but we can represent them in three ways. There's the parametric form, this one, and then there is the symmetric form. Okay. Then there's a Cartesian point normal. I think we're used to this one. We're used to this one. The parametric form, which is the one that is more important, it's represented like this. So this is a vector, or sometimes I can just put an x representing a vector. This is equals to x1, y1, z1, which is the point on the line, plus t, a, b, c. A, B, C is like a vector that is parallel to a line. So imagine you have a line like this here. Then you have a point. This would be a point, x0, x0, which is this point here. This will be a point. And then a vector will be this one. So you need two things. You just need this. You need a vector that is parallel to the line, and then you need a point in this format. You just got to be careful with this. This is not a line. This is just a vector. It's like it's something that shows direction. In this case, it says the direction is this way. The direction is parallel to the line. So that's all you need with parametric. And then symmetric is similar to parametric. You have this x, you subtract this x1, you divide by this a. And then you do the same thing with y. Take this y, you subtract this, you divide by the b. They're kind of like related. You can move from parametric to symmetric. I'll show you once we start with the question in a moment. And then we have the last one, which is the Cartesian point normal. This is the one we are used to. This is the one we are used to, this one. It's ax plus by plus c is equal to 0. In 2D, in 3D, you have to add an extra variable set. Then you can make the constant d, whereby AB is a vector that is perpendicular to the line. So you have the line like this, then some perpendicular vector will be your AB, right? Sometimes it can be represented as y is equals to mx plus c, but it's just the same thing, because you can, for example, you have, let's say you have y is equals to 2 over 3x plus 2. You can turn this into this by just multiplying out by 3. This is the same as 3y minus 2x minus 2 is equals to 0. So basically, it's the same thing. It's the one that we used to. It's a Cartesian, or sometimes called point normal form, because of this normal. Because a perpendicular vector is also called a normal. And then the last thing we need when it comes to lines is we need to be able to find a distance. You might have a line like this, and say you have a point here, P, And then of course you need a vector every time to describe a line. Let's say the vector is let's say the vector is called the vector A, right? And then maybe some random point, let's say Q, right? You might need to find the distance between this line and the vector. Sorry, and this point. Basically, you might need to find the distance between this line and this. So you use this formula. That's if the equation that you have is in parametric or symmetric form, like this. Because it will be easier to, now you have, if you have PQ would be this. Now you have your point, which is P. You have your Q, which is this point. You have your A, which is this vector. I mean, even from here, you can read, because these two are related. You can read a point, you can read a vector, which is A, B, C. And then when it's in Cartesian format, you just use this formula. This would be the point. The x1, y1, z1 will be the point. And then the A, B, C, D will be this. This A, B, C, D. Then the x1, y1 will be the point. In this case, Q. So that's all you need with lines. And what's left for us to do now is to do some questions so that we can see how this thing's done. I'm just gonna share the screen. Doesn't work. I'm just gonna do the questions here. Let's start with the basic ones. Oh yeah, there it is. Suppose you have a line. Well, they'll put it in words, obviously, right? I'm just gonna summarize the question here. You have a line like this. Let's call it line L. Then they give you a point. What's the point? They give you a point A. They say the point A is on the line. So -2, 1, 4. And then what else do they say? They say this line is parallel to some vector. It's parallel to some vector. I'm just summarizing because it's when you put things in drawing, it becomes clear to see. They're saying it's parallel to this vector, and this vector is 2i plus 3j plus k. And then they say find the equation of this line. Yeah. So the equation of a line, this is the answer now. YZ is equals to x1, y1, z1 plus t a, b, c. So in this case, our equation will be x, y, z is equals to, this is the point on the line. In this case, is our a, -2, 1, 4 plus t. And then this is a vector that is parallel to the line. In this case, because this can also be the same thing as 2, 3, 1. So we can say 2, 3, 1. Then we're done. Sometimes you can write this if you want as x, but this is good enough. Is equals to, you take this -2 plus t times 2 is 2t. You found your x. And with your y, it will be 1 plus 3t. Then z is equals to 4 plus t. Sometimes they can represent it like this. you just need to be comfortable to work with both of them, because this is the same thing as this. You can just look for your point here. The point will be any number that doesn't have a t next to it. And then your vector that's parallel to the line will be any number that is attached to the t. Basically, that is a coefficient to the t. Just need to be careful that the sign before that number must be positive. So in this case, if we had a negative, if we had e.g., if we had something like y is equals to, I want to say 2 minus 3t, your b is equals to minus 3, because this is the same as 2 plus minus 3. Just need to make sure there's a plus in between. Then your b will be this. But in this case, this was simple. Then the next question will be this one. It says, now they give you two, I think they asked it in the exam as well. Actually, lines are not that difficult. They give you a line. Put it in a different color. They give you a line. Let's say L. Then they give you a point. The point is A. Minus 1, 5, 2. Then they give you another point, B, on the line. And then 2, 1, minus 3. So they give you 2 points. And then they say find the line, the equation of the line. Right? They do the same thing. The equation of a line is like this. It's equal to x1, y1, z1, then plus t, a, b, c, right? So this is the point on the line. We've got 2, so you can just choose any, right? And then how do we find this? Well, this is just it's a vector, remember. It's a vector parallel to this. We can come up with a vector because now we've got 2 points here. We can come up with this vector by saying vector AB, right? AB gives us a vector. That vector, this thing is the same as B. You start with the last letter, B minus A, right? Which is equals to 2 minus 1, that is 3. Then 1 minus 5, that's minus 4. Then minus 3 minus 2, that's minus 5. And then now we've got your vector, which is parallel. There is parallel to the line. Now we've got a point. And now we can just you just choose any point. I'm just going to choose this one. Minus 1, 5, 2, plus t. With the vector, there will only be one vector. And it depends on where you're starting with your point. You start this side, this is going to be negative, this is going to be positive, this is going to be positive. But it really doesn't matter. You just need to know what you're doing. Because for example, you might not see this option in the multiple choice, this one. So you need to understand, oh, okay, what they did here is they used this point, because it could be 2, 1, minus 3. There could be a lot of variations, you understand? And it could be 3, minus 4, minus 5, right? That's another option. Someone else might have said, that this line, who said it's going this way? I mean, it could be going this way. Another person could have just said BA. I want the vector BA, right? So in that case, it would be A minus B, which when you have AB, you just negate all the values there. Okay, minus 3, 4, 5, right? But still, this vector, it's a vector, right? It's parallel, but it's facing the other direction. It's parallel. So someone else could have said, oh, minus 1, 5, 2 plus t. And then they put minus 3 here. 4, 5, or 2, 1 minus 3 plus t minus 3, 4, 5. But yeah, that's how you approach this one. And then what else do we need to know? Now, you also need to know, let's say we are given 2 lines. Let me see. Let's say you're given 2 lines. Let me just, I want to erase this because I want to work on this area. I'm just going to erase this. Right. Imagine now we're given 2 lines. They might give you 2 lines. They might say there's a line 1. Then they might give you another one. It's line 2. Line 2, right? Line 1. They might say line 1 is line 1. X, Y, Z is given by given by what? It's given by 1. Oh, 10 minutes left. Damn. 4 minus 5, then plus t t1, 2, 3, and then this one will be L1, sorry, L2, which is X, Y, Z is equals to 5 minus 3, 6 plus t, then 2, 5 minus 1. So they might give you these 2 lines, right? And then they say find the angle between these 2 lines. Find the angle between these 2 lines. So that means if they say find the angle between these 2 lines, it means these lines, they actually like this. It means, as you can see, these lines are not parallel. You can see, look at this line, look at this. 1, 2, 3, 2, 5, 1. If these lines were parallel, right, we would have something like T, 1, 2, oh, sorry. We would have something like T, just talking about this, 1, 2, 3. And then this one here would be T, basically multiple of this one, maybe 2, 4, 6. You see that this one is a multiple of this one. They took 2, they multiplied this by 2, and then they got this one. So that means that these lines will be parallel, but in this case, they are not, as you can see. So, and then they are finding they say we must find the angle between the two lines, right? So what it means, yeah, what it means is that these lines, they somehow slanting or skew crossing. We don't know if they're skew crossing, but we know there's something like this, right? And then now they're saying we must find the angle between these two lines, right? So how can we find the angle between those two lines? We can find the angle between these two lines by making use of these two vectors, because we know how to find the angle between the vectors. In this case, we know that there's a vector that is parallel to the line L1. It's like this. And then we know that this is a vector, it's parallel to L1. There's another vector that is parallel to L2, right? So we can find the angle between these two lines. Just make sure that when you're finding an angle, these vectors must not point towards, they must point away, they must point in the same direction. For example, you know vectors, you can move them around. So let's just move this one. Make the color. Let me say I'm moving this one, right? There it is. But it's just a vector. It's not a, you can move it up and down. Then the other one, let's say it's here, right? They're starting from here. When you want to find the angle, which is theta, between these two vectors, which is the same angle between these two lines, you must make sure that they are pointing away from this point, all of them, or they are pointing towards this point. In this case, I'm just going to choose away, right? So now we have this vector. When we have this vector, so we can find let's say vector A and vector B. We can find the angle by saying, if we cross vector A, sorry, if we dot the vector A and vector B, the answer is the magnitude of vector A, the magnitude of vector B, and then cos theta, like this. And then we can just we dot this two. It's going to be 1 times 2, which is 2, plus 2 times 5, which is 10, plus 1 times minus 1, that's minus 1. And then now we need to find the magnitude of A. We can choose A to be this one. Wait, it doesn't really matter, to be honest. We can just choose A to be this one. 2, 5, minus 1, B, 1, 2, 3. So the magnitude, we just say our A is going to be 2 squared plus 5 squared plus minus 1 squared, right? Then our B will be 1 squared plus 2 squared plus 3 squared, then multiplied by cosine theta. This side, 2 plus 10 is 12, minus 1 is 11. And this one is 25 plus 4, that's 29, right? 25 plus 4, 29, and then 30. And then this one is 9 plus 4 is 13. And this one is 14. Then cos theta. And then that means cos theta. Just gonna divide everything by this with 30. root 14. Then our theta will be the arc sine. The arc sine of this whole thing. Root 30 and root 14, right? That will be the angle between the two lines. And then what else do we need? Yeah, we left with maybe 10 minutes. You can see the board, right?
Yeah.
Okay.
Before you say that,
Okay. Yeah, I can. Yeah.
Yeah. I wanted to can you please do maybe something for intersection when they say the line they intersect or they don't intersect?
Oh, okay. I was about to do that. Can I just do this one first? I think I was gonna
Okay.
do that last. Yeah. Yeah. So we have something like this. I'll just do one. We have let's say this line, it's equal to I minus 2j plus 2k plus lambda 2i plus 5j minus k. Right. Then they say change this to symmetric form. Right. This one, you can see this one is in parametric form. Another way of writing it to make it clear is to say this is the same as 1 minus 2 plus lambda, which can be t. Then you've got 2, 5 minus 1, right? We need to change this to symmetric form. A symmetric form, you just it's very easy. It's very easy. You just say x minus this number minus 1 divided by this, which would be a2. That is equal to y minus this number, which is going to be 2 plus 2. Did I say minus? Yeah, it's supposed to be minus over 5, which is equals to z minus 2 all over minus 1. That's your symmetric form. Do you have any questions on that? How this thing came about? Maybe I can just show you a little bit fast. This thing came about because if you have, remember the original format of the equation is like x, y, z is equals to x1, y1, z1 plus t, a, b, c, right? And then you said x can be this x1 plus at, then the y can be y1 plus bt, and the z can be z1 plus what is it, ct, which implies that if you solve for t, you take, it's going to be x, take this x1 to this side minus x1, then we divide, once the x1 is this side, we divide by a, we'll be left with t. The same thing with this one, we'll be left with t z minus Z1 over C will be left with T. So now because all these T's, it's the same thing. So that means this is T, this is T, this is T. That means they are equal, which is why you end up with a symmetric equation saying x1 over A is equals to y minus y over B, which is equal to Z minus Z1 over C. So when you have a parametric equation, you can quickly change to symmetric using this formula. So now let's do the question asking about parallel lines. Let me just share this. Can you see this picture? Just copy it. Okay. Just erase this. So lines can be parallel, and I showed you when they are parallel that the vector is called this vector A, and then the other one is called vector B. When they are parallel, it means vector A vector A is equals to maybe some constant. We're gonna call it lambda. Lambda B. That means they are. Now let's call it T. T is much better. You're gonna have something like this if they are parallel. I showed you. So when they intersect, if they are not parallel, that means they are either they intersect or they askew. Intersect, which means they have a common point. When they askew, it means they don't touch and they don't have a common point. I created a bridge here. One is like on top and the other one is under the bridge. So now let me look for a question that deals with that. Yeah, there it is. So you might have something like let me remove this. You might have something like maybe we have line 1, which is equals to 1 minus 2, 4 plus 5, 1 minus 3. Then you have line 2, which is 17, 4, 5. Then you've got maybe new 6, 4, 7, something like this. And then they ask, do these lines intersect? I'm gonna do these lines intersect. If they do, what is the point of intersection? They might ask you something like that. Interesting. How do we solve something like this? If lines are if they intersect, we know we have line 1, then we've got line 2. If they intersect, that means they have a common point. In other words, it means L1 is equals to L2, right? So now we can do exactly that. There is L1, 1 minus 2, 4, plus 5, 1 minus 3 is equals to 17, 4, 5, plus mu 6, 4, 7, right? And then we can just combine this. This would be 1 plus 5 lambda minus 2 plus lambda 4 minus 3 lambda. Just combine this vector. Then do the same thing this side. It's going to be 17 plus mu. I want to say 6 mu. Plus 6 mu. Then 4 plus 4 mu. Then 5 plus 7 mu. Right? This equation basically says we start with those 1 plus 5 mu is equals to 17 plus 6 mu, and then minus 2 plus lambda is equals to 4 plus 4 mu, 4 minus 3 mu is equals to 5 plus 7 mu. And then from here we have 3 equations. We've got equation 1, got equation 2, we've got equation 3, right? And then we have 2 unknowns. Remember now we created equations, but then we have 2 unknowns. And you know when you have 2 unknowns, that means you need only 2 equations to solve, right? So or you only need 2 equations to solve. So I'm gonna just erase this one here. Back. So I'm just gonna choose this one. In this case, which one is simple? Yeah, I'm just gonna choose 1 and 2. Gonna say 1 plus 5 lambda. Let me do this. I want to solve these 2 equations simultaneously. Which one is easier? This one is much easier. So I'm just gonna say 5 lambda minus 6 mu is equals to 17 minus 1, which is 16. And this is equation 1 basically. And then the next one will be lambda minus 4 mu is equals to 4 plus 2, which is 6. It's the same equations 1 and 2, but I just wrote them differently. Gonna solve these two. I'm gonna solve them using elimination. I'm gonna multiply this one by 5. I'll leave 1 as it is. Then multiply this one by 5, which will be 5 minus 20, which is 30. This is 3. Right. So it's a new equation. Now I can say 3 or 1. Which one? Let's say my 1 minus 3. This minus this will go. Minus 6 minus 20, that will be minus 6 plus 20, which is 14 mu. Then 16 minus 30, that should be minus 14. This thing record. Yeah, it is. Which means that mu is equals to minus 1. And then now, because you have mu is equals to minus 1, we can choose this one. Or this one. I'm just going to choose this one. Sub into 2. That means minus 4 minus 1 equal to 6. That means our lambda is equals to 6. This will be plus 4 minus 4, which is equals to 6 minus 4 is 2, right? So now we've got lambda minus 1. Sorry, we've got mu, which is equal to minus 1, and then we've got lambda, which is equal to 2, right? And then we need to check if these two satisfy equation 3. Check. If they do, it means these two lines cross. It means that this first equation that we did here was correct. But if they don't satisfy equation 3, yeah, it means everything's wrong. Left-hand side is equals to 4 minus 3 lambda, which is equals to 4 minus 3. My lambda is 2. We get what? 4 minus 6, which is minus 2. Let's check the right-hand side. The right-hand side will be 5 plus 7 mu. This is equal to 5 plus 7. Mu is minus 1. 5 minus 7 is equals to minus 2. Therefore, indeed, because they satisfy 3, means the lines intersect. Means this equation that we assumed. Let me just, this was an assumption. Let me just say assumption. That means this equation that we assumed is correct. If they didn't intersect, these two were going to be different. That means they are skew. If they don't intersect, it's either they are skew or parallel, but it's easier to look for parallel. And then now the question said we need to find what the point of intersection. Well, the point of intersection, you can just use any one of this and replace. In this case, I'm just going to use this one. So you just use any equation there. This one. 1 minus 2, 4 plus dang, our lambda was what? Our mu was -1, then our lambda was 2. I'm not mistaken, let's say 2. That's -6, yeah, it was 2. So now I just take this 2 and put it here, 2, 5, 1, minus 3, which is equals to 1 plus 10 minus 2 plus 2, 4 minus 6, and that will be 11, 0, minus 2. That's the point of intersection, this point. You could have used this one as well. We give the same answer. Let me show you. 17. If they do intersection, you get the same answer. Then this time we're using mu, which is -1. 6, 4, 7. This will be 17 minus 6, 4 minus 4, 5 minus 7. Then this 17 minus 6 is 11, 4 minus 4 is 0, 5 minus 7 is -2, which is the same. So yeah, that marks the end of the lesson. Thank you.